Welcome back, Patriots. This is Mr. Love, aka the Math Patriot, bringing you another fun and exciting lesson in the world of high school math. This lesson I am not going to be doing live in front of a class. The reason being, I am actually not going to be in class, so my live class is going to be just watching this video off of YouTube with a substitute. I know, exciting stuff. So let's go ahead and get this done. Similar triangles. So last class period, we talked a lot about ratios and proportions and also similar figures. And remember, similar is this symbol here. And also when we have a similarity statement like triangle ABC is similar to triangle XYZ, we get 6 pieces of information out of this. Our corresponding angles are congruent. So angle A is congruent to angle B is congruent to angle, I'm sorry, I said that backwards. Angle A is congruent to angle X, congruent to angle X. Angle B is congruent to angle Y, and angle C is congruent to angle Z, all the corresponding pieces. Also, we have our line segments are proportional, which means that line segment AB, positions 1 and 2, over XY, also position 1 and 2, is equal to BC over YZ. This is position 2 and 3 on both, which is also equal to the wraparound AC is equal or over ZX. So that's what our similar triangles do. Let's just explore these a little more. Now, the purpose of what we're trying to do today is to prove or identify similar triangles using some similarity shortcuts. Now, just like with triangle congruency, we started off with CP-CTC, and we do not like CP-CTC. Corresponding parts of congruent triangles are congruent. We do not like that for proving that triangles are congruent because it's just flat out too much work. We would much rather go with our 4 congruency shortcuts, which are side, 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 angle, side. The other ones were angle, side, angle, and also side, angle, angle. Those guys work. Remember, there were 2 that did not, angle, 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 as well as side, side, angle. Those did not work. Those did. Now, when we're talking about similarity, though, we have 3 congruency shortcuts, and those are angle, angle, side, 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 and side, angle, side. Now, these work just slightly differently than they did back in our original unit with congruency, so be paying attention when we get to that on what the slight difference is. First off, if 2 angles of one triangle are congruent to 2 angles of another triangle, then they are similar. So basically, I only need 2 angles to prove similarity, because what this does is essentially the third angles theorem forces angle C and angle H to be congruent to each other. And then I know that my angles are equal, and therefore we have similar figures. One's bigger, one's smaller, and we're good to go. They are similar triangles. So let's go ahead and do this one. Determine whether the triangles are similar. Now, looking at this, I can go ahead and say that angle B is congruent to angle D. I can see that. They're both 42 degrees. However, I'm seeing that E is definitely not congruent to C, but let's go ahead and do some subtraction here and figure out what the measure of angle F is. Angle F is equal to 180 minus 80 minus 42. So whenever I subtract those, that means the measure of angle F is going to be 180 minus 80 is 100 minus 42 is 58 degrees. Now that tells me that angle C is congruent to angle F. And since I have 2 sets of congruent angles, I now know that triangle ABC is similar to triangle. Let's make sure we get these in the corresponding parts. Angle A is going to correspond to angle E. Angle B is going to correspond to angle D. And then that leaves my F on the end. So ABC is congruent to DEF by angle, angle, similarity. So very similar to what we were doing back with our congruency, just looks a little bit differently. All right, determine whether they are similar. If so, write a similarity statement. So here's what I'm seeing here. Angle QXP, which is this angle here, is going to be congruent to angle NXM, which is this angle here. I know that by the vertical angles theorem. Now I'm looking and I see that I have two sets of, or a set of parallel lines, and then line QN is going to be a transversal that cuts across them, which means that here angle Q is going to be congruent to angle N based on the alternate interior angles theorem. So angle Q is congruent to angle M, and that is an alternate interior angle. Therefore, I know that the two triangles are congruent by angle similarity. So I would say that triangle QXP is similar to triangle, let's say Q corresponds with N, X corresponds with X, and then M, and that is by angle similarity. Actually, now that I write that, I'm questioning, did I write that wrong earlier? Nope, I did write similar. I was afraid that I'd accidentally wrote congruent there out of habit. Okay, those guys are similar. Okay, moving on to theorem 7.2, side similarity. If the corresponding side lengths of two triangles are proportional, this is the big change right here. This says proportional, not congruent, which means that they essentially reduce down to the same scale factor. Remember, we're worried about reduced fractions, not the original fractions, not the non-reduced ones. Then they are similar. So if I've got three sets of corresponding proportional sides, then I've got similar triangles. Sideangleside is the exact same pattern as what we saw with Sideangleside on the congruency statements or congruency shortcuts. The only difference here is that we have the side lengths of two sides of a triangle are proportional, again, not congruent, but proportional, as well as knowing that the included angle is congruent, important word there is included, then they are similar. So we've got our exact same pattern here. Two sides and an included angle, two sides included angle. Only difference here is we've got the proportion to worry about instead of straight up congruency. So let's go and practice those. I'm going to tell you right now there are two different ways of doing number 3, and I am actually going to choose the longer way just to show you how it works. And then after I'm done with that, I'll come in and show you what the shortcut to that was. So whenever I'm looking at this, I see that I have 3 sets of sides that are marked, and I know the exact lengths of them. So in order to test whether they're similar, I'm going to use my side similarity. Now I want to look at my short, medium, and long sides on these, and I'm going to go ahead and classify or categorize those so I know which one is which. When I'm looking at triangle ABC, it looks like 6 is my short side. Over here on the right-hand triangle, looks like 4 is my short side. Medium over here is going to be 7.5, and then 5, and then long, do that in pink, is going to be 9 and 6. I need to test those proportions, short, medium, and long. So again, it doesn't matter which one you choose as long as you are consistent with your fractions. I'm going to, in this case, put my left ones on top or in the numerator every time. So 6 over 4, that is going to reduce down to 3 halves. Now with my medium sides, I've got 7.5 over 5, making sure the right one stays in the numerator. That one, sure enough, if you don't believe me, you can test it in your calculator. That is going to reduce down to 3 halves. And then my long sides, we've got 6 divided by 9. That's a factor of 3. I'm sorry. See, I did that wrong. I put the right-hand side one on top. I need to do it the correct way. The left side's on top is 9 over 6, and that reduces down once again to 3 halves. So since I have 3 sets of proportional sides, I know that because all of my reduced fractions or my scale factors are the same, then I have similar triangles. So the way I would write that, triangle ABC is similar to triangle. Now it looks like A is going to be between my short and long, which is going to correspond with D over here. And then B is between long and medium. Between long and medium is E. And then my odd man out there is C, and that is by the side similarity theorem. Okay, that's the long way. There's actually a slightly shorter way. So I could have chosen to get rid of this 9 and this 6 and not worry about them, and then use that angle ACB is congruent to angle DCE, and then use my shorts and my mediums, the 6 and 4, the 7 and 5, and use side angle side to do it. I think that's a little bit easier because the vertical angles are just going to make it work out. Okay. Determine whether they are not, if so, or if they are similar, if so, write the similarity statement. Same thing as above. Okay, now, as I'm looking at this, I see that angle M is shared by both the small and the large triangle. So I know that angle M is congruent to itself, and that is by the reflexive property. Now I need to look at the left-hand and right-hand sides of these things. So I can see that I believe my corresponding sides here are going to be, let's do my colors here, MN and MR. So we've got MN over MR. That is going to equal, I guess I should probably do my colors right there. That would be MN in orange. MN is 10. MR is going to be 10 plus 15, which is 25. Now that is going to reduce down to, let's see, a factor of 5 would be 2 over 5. Now over here, again, I've got MP and MS. So we've got MP over MS. So MP is 12 over MS is 12 plus 18, which is 30. And that looks like I've got a factor of 6 on those. So pull out the factor of 6, and I've got 2. Divide 30 by 6, and I've got 5. So yes, I have the common reduced ratio there. And so I've got a set of sides on the left, a set of sides on the right, and then my included angle, which means that triangle NMP is similar to triangle. N is going to correspond to R. M corresponds to itself, and then P corresponds to S, and that is by side angle side similarity. All right, let's look at number 5. Now, on this example, as well as on number 6, you're going to have to forgive this statement here if they are similar. The reason I say it doesn't make sense is because you're saying if they're similar, then which two are needed to prove that they're similar. It doesn't exactly work out, but it doesn't quite make sense. So just kind of forgive the bad wording there. What I'm going to do here is draw my two triangles, and yes, we're going to pretend that that is actually a straight side. R, S, T, and then X, Y, Z. And I'm putting those in the same orientation so that R and X are in the same place, S and Y end up in the same relative position. It also tells me that RS over XY is 2 over 3, so this is 2 and this is 3. So given that information, what would be sufficient to prove that the triangles are similar? So let's go through here and look. If I've got the angle R, I'm looking at C first. It looked like the easiest one to do. If I know that R is congruent to S, well, that's not going to do me any good. First off, that's an angle side angle. In one triangle, I have just a side in the other, so that's not going to help me out any. So we know that this guy doesn't work. Not enough information. Not enough info. All right, now let's look at option A. If RT, which is here, is over XY, Well, I can already tell that that's not going to work because those are non-corresponding parts. So these are not corresponding, so that does not work. Oops. And then let me see if I can get rid of. Oh, not going to work. Oh, well. Actually, no, I really don't like that. I'll just redraw these triangles to get rid of the blue marks. Okay. Now, let's go ahead and look at option D over here. RS over RT. So RS and RT over X equals XY over XZ. Again, this information is not going to help me out very much because I know that I have two sets of corresponding parts here, but I know nothing about either an angle or a third side, so I don't have enough information here. So again, this is not enough info. And oh, look, I did it again. I'm going to have to erase my entire triangle to get my marks gone. So that means I'm really hoping it's B, but let's see what we've got here. RS over XY, so these two are proportional. RT and XY, or XZ are proportional. And then ST and YZ, all those are proportional. So yes, this guy looks like the correct one because it shows me that we've got three sets of sides that are proportional. So that works by side, side, side. Also realize I put these markings. I'm kind of taking a little bit of liberty with my notation here. I'm not saying that these two are congruent. I was just marking those and color coding them so I could keep track. So please forgive me for that notation liberty I took there. All right. Number 6. Given that triangle ABC, oh yeah, again, we said we're kind of ignoring that for a second, which would be sufficient to prove that triangles are similar. Okay, so first off, looking at this, I know that both of my angles coming out of C are going to be congruent by vertical angle theorem. So that's good. Let's see what I can find out here. Option A, AC, and I'm going to kind of take the same liberties in my notation here. AC over DC is equal to 4 over 3. Again, I don't have information only about an angle and a side, so that's not going to help me out any. Not enough info for A. That's not it. B, 2 times the measure of angle A equals 2 times the measure of angle D. So if I put an X there, then this would be 2X. Again, I've got information about two angles, nothing on sides, so I don't have any of my similarity shortcuts. So we're not going to be angle or part B. D, BC over DC. So BC over DC is 5 over 4. Again, only one set of sides information there, so that does not help me. Now let's jump over here to AC. So AC over EC is equal to BC over, did I mark that wrong? Hold on, let me start over on that. AC over DC, there we go, sorry about that, is equal to BC over EC. And so now, yeah, it looks like I've got side, angle, side, side, angle, side. Hey, that looks like that works to me. So this one is going to be correct, and that is going to show side, angle, side similarity. All right, now just realize our reflexive, symmetric, and transitive property, they apply to similarity too. You've seen these before. Same song, just different verse. All three of those properties apply. All right, let's see what we got here. Example 7. Given that these two lines are parallel, RS is parallel to UT, RS is 4, RQ is x plus 3. We've already got it marked. QT is 2x plus 10, and UT is 10. Okay, great. All that's marked in there. Find RQ and QT. So I'm going to find the distance from RQ and QT, which tells me I've got to solve for X somehow in here. So let's see first off if we got any sort of similarities going on. I know they're not congruent, obviously not. Okay, first off, my two angles at Q are going to be vertical angles. That's great. I also know that since I have parallel lines and US is a transversal, that angle S and angle U are congruent. And by the exact same logic with TR being my transversal, these two are congruent, angle T and angle R, which means that triangle UQT is similar to triangle, and let's make sure we match this upright. U matches with S, Q matches with Q, and then R matches with T. Now that's important for us to write that out because we want to make sure we get all the right corresponding parts in here. Thankfully on this one there's only two parts of each triangle and I can kind of figure it out just by looking, but I want to just make sure that I'm accurate with the way that I set up this proportion. So let's see, looks like RS is position 1 and 3 over UT is going to be equal to, here I've got QR, and QR is position 2 and 3. It's going to match with QT, so QT is down here, and I can go ahead and use that to fill in my proportion. RS is 4 over UT is 10 equals QR is X plus 3 over QT is 2x plus 10. Now keep in mind there's a lot of different ways to write that particular fraction to kind of set this proportion up. In particular, I put the triangles on the right in the numerator. You could have put the ones in the left in the numerator as long as you're consistent. What matters here is that when you cross multiply this thing, the 4 is going to multiply by the 2x plus 10 and the 10 multiplies by the x plus 3. And if you have it set up so that happens in the cross multiplication, you did it just fine. All right, now let's go ahead and cross multiply this. I'm going to distribute as I go. 10 times x is 10x. 10 times 3 is 30, which equals, distribute here, 4 times 2x is 8x. 4 times 10 is plus 40. Now we're going to solve, subtract that over, and I get 2x. When I say that, subtract 8x from both sides, subtract 30 on both sides, and I get 10 on the right. Therefore, x equals 5. Now I'm asked for QT and QR, so I need to go one more step. QR is equal to x plus 3. Ooh, that was really bad handwriting there. X plus 3, which is 5 plus 3, so QR equals 8. There's one of my answers. QT is equal to 2x plus 10, which equals 2 times 5 plus 10. So that means QT is 10 plus 10, which is 20. All right. Let me give you all a second to copy that because I know that was a lot. I hope I didn't go through it too fast. Kind of hard to gauge whenever I am sitting at home in front of a computer. By the way, if you need to pause it, feel free at any time. All right. Number 8. ABC is similar to DEF. Find the values of X and Y. So I'm going to look at this and see that BC corresponds with EF. So BC corresponds with EF. I'm going to use that as my scale factor. And so that reduces to 2 over 1. Now I'm going to use that reduced scale factor for all of my ratios here, all my proportions. Let's go ahead and go with AB. So AB is position 1 and 2, corresponds to DE. DE is 18. So since I did the 18 and 9, the left-hand triangle is in the numerator, I got to be consistent with that. So y over 18, which came from here and here, is equal to my scale factor, which is 2 over 1. So we cross multiply, and we get y is equal to 36. Simple enough. Now let's do the other one, our final one. So we're going to do 2 over 1 is equal to, left hand is on top, 18 over root 3 is equal to x. Now I know that this root 3 in there can kind of freak you out. Just roll with it, pretend that root 3 is a variable, and it'll all just work out. 2 times x is 2x equals 1 times 18 root 3, so that's just 18 root 3. Then divide by 2, those cancel out, gives me x is equal to, and then 18 divided by 2 is 9 root 3. The reason the 2 divided into the 18 and not into the 3 is because this 3 is is inside the square root, and the 18 is not, and neither is the 2. So those two went together. So we got 9 root 3. Box that so you can read it. Okay, moving on. Number 9. A person 6 foot tall casts a shadow that is 1.5 foot long. So basically, here's what's going on. I could go to the trouble of drawing all this fancy stuff. Really, anytime I'm doing these, I'm just going to draw very basic, simple triangles. I've got a person that is 6 feet tall and has a 1.5 foot shadow. We've also got at the same time a flagpole that casts a 7 foot shadow. How tall is the flagpole? Now, here's one thing that we have to make sure we do. We're going to assume that that when we measure height, we're always measuring it straight up from the ground, a perpendicular distance, because that's what the definition of height is. So the ground and the person and the flagpole is going to be a 90-degree angle. Now, the other thing that we're assuming here is that essentially the sun, way off in the distance out here, is coming down and hitting them at the same angle. So as my sun rays come in, they get here, come down, and that's where the tip of the shadow is. So we're assuming that this angle and that angle are congruent because the sun is at the same angle to the top of the person's head and the top of the flagpole, which means that I've got two angles that are equal. I've got I'm sorry, I can't say it. What's the word? Angle, side, angle. No, side, angle, side. Never mind. I don't need to worry about that. In these scenarios, yes, there are going to be some more triangles. Take my word for it on it. I can't think of the word right now. Forgive me. It's like nearly 11 p.m. right now, and I'm ready to go to bed. Okay. Anyway, there's some more triangles. And, it's side, angle, side. Boom. That's what we got. Side, angle, side, whatever. Moving on. We're going to go ahead and set up a proportion in order to solve for the missing side length here to find the height of the flagpole. So, again, left over right equals left over right. 6 over x equals 1.5 over 7. Cross multiply gives me 1.5x is equal to 42. Divide both sides by 1.5, so x is equal to 28. So it is 28 feet tall. 28 foot tall flagpole. Really sorry for flipping that one up. It'll make more sense as we go through. Example 10. The heights of two vertical posts are 2 meters and 0.45 meters. So we've got two posts, and it says they're vertical, so I'm assuming there's the ground there. This is going to be 2 meters, and then this one is going to be 0.45 meters. When the shorter one casts a shadow that is 0.85 meters long, shorter one would be this one over here, 0.85 meters. What is linked to the other post shadow? So we're going to put our X here. Again, we're assuming that light is, or the shadow is being cast down at the exact same angle on those. And so let's use our proportions. Again, left over right equals left over right. 2 over 0.45 is equal to X over 0.85. Cross multiply, 0.45x is equal to 2 times 0.85. So 0.45x is equal to, multiply that through, and we get 1.7. Divide both sides by 0.45, and then x is 3.78 meters tall. So same thing as before, just different numbers on it. All right, only 2 more examples. Identify the similar triangles, then find IU. So looks like we got the small triangle and the big triangle. I already know that angle G is congruent to itself by the reflexive property. It also looks like I need to do my, let's see, I need a side angle side here. So for GW over GU is going to equal 26 over the whole thing, which is 39. Then let's see, if I reduce that, that is going to be a factor of 13, so that's 2/3. Now, because these are equal, this is 26 and this is 13, so GH over GI is the exact same numbers. 26 over 39 reduces to 2/3. Therefore, I know that triangle GHW is similar to triangle GIU. That means that I can essentially use a proportion to come up with the value of x. Now we got to be careful here. We got to use GW and GU, which is 26 over 39 is equal to, and then the smaller triangle is 20 over x. You know what? I'm going to be smart about this. Instead of using that, I'm going to use the scale factor. That's 2/3. No. Yeah. So then, cross multiply, 2x is equal to 60. Therefore, x equals 30. All right, last problem of the day. Identify some more triangles and then find QP. Well, first off, let's go ahead and identify our triangles. So we know that angle F is congruent to itself by the reflexive property. We've got a parallel line, or 2 sets of parallel lines, and so my transversal means that the corresponding angles are congruent, and so great. We got angle, similarity, so I know that triangle FRQ is similar to triangle F, and then NP, that's by the angle. And let's go ahead and see, X is over here in this position. Now, what we got to be careful of on this is that when we set up our ratios, the small triangle FQ, you know what? I'm actually going to write this out. FQ over FP, that's positions 1 and 3 on both. And I got information on these top sides. And then so then I got FR. FR is position 1 and 2, which would then be FN on the other triangle. Now, when I set up my fractions with numbers in it, I'm going to do this FR and FN first because there's only numbers in it. So FR is 30, And then Fn is going to be 30 plus 10, which is, I'm just going to go ahead and write that out. We're going to reduce that to 40 in a second, or simplify it. So this is a composition of those two, the sum of them. Now, when I do FQ, that is 32. But when I go and do FP, that's going to be 32 plus X, or X plus 32. So we're going to make that a 40. Now, also for simplicity's sake here, I am going to rewrite this as 32 over X plus 32 is equal to 30 over 40 reduces to 3/4. I think reducing that's going to help me a little bit here. Let's cross multiply. 32 times 4 is, I think that's 132. Oops, I don't have my calculator up, so forgive me for a second while I do some calculation here. See, I was wrong. 8 and then 128. And then 3 times x plus 32. 3 times x is 3x. 32 is going to be, 3 times 32 is 96. Now, it gives me, subtract 96 on both sides, gives me 3x is equal to 128 minus 128 minus 96 is 32. Then we're going to divide, and it gives me x equals 32 over 3, 32 thirds. So that tells me that QP, which is where x was over there, QP is equal to 32 thirds, or if we want to reduce that, make it an improper fraction, is 10 and 2 thirds. Either one works there. Okay, there we go. That's everything. In summary, the thing you need to keep track of, you've got your angle-angle similarity, side-side similarity, side-angle-side similarity. The angles are congruent in all of these, so actually in this one and this one, the angles are congruent. But if I talk about the ones that have sides in them, so here are the sides on both of those, that implies proportionality. So we have our fractions or our ratio set up and not congruency. That's it for now. For all of my in-class people, you're about to start the assignment with work on the rest of the class, which is right there. For all of my YouTube people, I don't have the right to give you guys assignments. You can do homework or something like that if you want. Either way, as always, please stay patriotic.